Welcome everyone. Today we're going to be talking about congruent angles and angle bisectors. So your goal after watching this video should be able to identify and prove that two angles are congruent, and you should be able to identify and prove when a ray is an angle bisector. So with that being said, we're going to start off with a real life example. You might notice on top that is Yankee Stadium, and in baseball we have an example of an angle. So you might not think about it this way, but going from home plate all the way to right field, and I should choose a different color that we can actually see. Going from home plate all the way to right field is like a ray. Wow, you still can't see that. And going from home plate all the way to left field is also a ray. And remember, two rays that share an endpoint, we just call that a vertex. There we go, that works. And an angle. So our endpoint here is our vertex, and that is actually an angle. So you might be thinking, okay, so what does this have to do with today's lesson? I know we talked about angles last time, but if we're thinking about congruent angles and angle bisectors, knowing exactly where the pitcher should be is important. Because he needs to be exactly in the center of this angle. And the same thing with second base. Again, needs to be exactly in the center of this angle, because we can't have second base being closer to first base, or it being closer to third base, for example. It has to be directly in the middle. And the only other way that we can actually do that, and this is actually a real-life application of two congruent angles, so these angle measures here, from here and here, those are both the same, and we call that ray in the middle that extends here. That's an angle bisector. So the big idea for today is here's an application, and here's how we would use this, of an angle bisector and two congruent angles. The same idea, if you look at the Great Pyramids, is we can break this down into an angle. Wow, and that was not great. Into an angle. And then if you're looking for the shortest way up this, directly up the center, or again, if you're, when they were actually building these, they would need to know these angle bisectors to make sure that they were building it not lopsided. Again, we would need our angle bisector going through the center here. So a big idea today, there are some good applications for angle bisectors and for congruent angles, but these are the two that came to mind for me right away. And hopefully that can kind of ground what we're doing today in something that's real. So with that being said, let's jump into our definition. We're going to start off with congruent angles. And we define these as angles that have the same measure. So if we're going to take a look at something like this, and we split it out, we would see that angle 1 and angle 2, as long as I drew that well, they would both have the same measure. You're going to see these marked with like little arcs. So as long as they look like that, they have the same little mark, we know that they're congruent. You might see it with 2 arcs. As long as they both have 2 arcs, we'll know that that's the symbol for them being congruent. They might even have 3. And again, if they have 3, they have the same identifying symbol, then we'll know that it's congruent. So again, identifying symbols are there, are there, are there, and are there. All right, so let's keep it going. So some steps on the bottom that are important to know. Angles that have the same measure are congruent angles, and arcs on the figure also indicate which angles are congruent. So if we look to the side here, we're going to see here is an arc and here is an arc. They both match. So that symbol there, that's what tells us that we have some congruent angles. And that's the idea. And it's proven to us because we see 25 degrees. So that's another way to see that there. All right, so let's do some congruent angle examples. And an important thing that we want to note here is the way that we write these congruent angles. So they're telling us to give a statement of whether they're congruent, and if so, tell us how. So first off, 47 degrees is the same as 47 degrees. So we know that angle, we have to start off not with our vertex. So angle TOH is congruent to angle DAB. In a couple different ways that you can write that, all of them are okay, as long as your vertex of each of these angles is in the center. Remember, this is the symbol for congruent. I know we did this from congruent segments a while ago, but that symbol, the equal sign with the little squiggly on top, is our symbol for congruent. The same thing for the next one, so you'd want to write a congruent statement. And then finally, here's an application where you'd have to do some math, is we see that, okay, so here's an arc and here's an arc. So for example, 2, those two are congruent, which means that 6x plus 2 has to be the same degree measure as 8x minus 14. So you're going to see they're going to set up some algebra like that, whereas if you have angles that are congruent or have the same measure, you're going to have to do some solving based off of that. So finish up B and also finish actually solving example number 2. And that'll be part of the form that you submit for watching this video. So those two things there. All right, our next skill, moving on to angle bisector. So we talked about this to start. That's how we kind of split the angle in half to create two equal parts. So angle bisector is the word. And we define this as a ray that divides an angle into two congruent angles. So again, we're seeing that here's an example of congruent angles. We get to them basically using an angle bisector. Okay, so for example, if we have a right angle that's 90 degrees, we draw a ray through the middle of it. It's going to cut it directly down the center if and only if these two measures are 45s, if they are exactly the same. So a bisector is, I'm going to highlight it, it is the ray that's in red. It's the one that basically cuts it in half. That's how I think about it. Just takes it, slices it directly in two, equally in two. And our next statement, so looking at our angle here, ray PQ is the angle bisector of angle RPS. Then we know that angle RPQ is congruent to angle QPS. That's just a really fancy way of saying that if this is a bisector, then we know that this angle and this angle are the same. And that's just how we identify that. And again, notice vertex is in the center. So again, angle naming conventions, we're being careful with those here too. All right, so some final example problems here. We'll go over the first of example 3, and that should hopefully get us set up for working through the remaining questions that we have in our notes here. So if the measure of RQT, which is this one, is 6x plus 5, and the measure of angle SQT is 7x minus 2, they want us to find the measure of angle RQT. Okay, so they're giving us some information. Another thing that we should see is up top here, QT is a bisector, so we know that this angle and this angle have to be the same if QT bisects it. So, let's go through. So we would have 7x minus 2 equals 6x plus 5, because this degree measure and this degree measure have to be the same. They have to equal each other. So we just go through and do some algebra to solve. So add 2 to both sides, 7x equals 6x plus 7, subtract 6x, and we'll get x equals 7. Okay, so we have an answer for x, but they want us to find RQT. Okay, so let's take RQT. They told us that that equals 6x plus 5. We know that x equals 7. So we have 42 plus 5 gets us 47. Is that reasonable? That's an acute angle measure. And if we take a look, angle RQT is acute, so that works for us. So our answer is actually right here. So we had to do two things. So first, we solve for x, and then second, we plugged in and found the angle of measure RQT. So to be very clear, the measure of angle RQT equals 47 degrees. Okay, so try to use that same methodology. Think about the way that we're going through and solving these, and think about setting these up. So if you have equal angles or unequal angles, when they're congruent, when they're not congruent, and that's going to help you set up when things are equal to each other or not. And a lot of times with the angle bisectors, we are looking for congruent angles. We are setting things equal to each other in order to solve. All right, so any questions, let me know. Feel free to reach out. Make sure that you're finishing up. I think there's like 3 or 4 questions to do that we didn't do in the video, and hopefully that should give you a good idea of the skills that we're learning for today. Thanks for tuning in, everybody, and